Hi, the next example is unknown time. So we want to solve the time diagram for the time point t. So example 2, determine t such that the two cash flow have the same value. Assume the interest rate is 5%. So the first cash flow, we have time point 0 and 6 and 9 and 12. And we have $10 payments here and $30 payments here and $40 payments here. Okay, so I is equal to 5%. And then we have X here. So X is the present value of the entire cash flow. Okay, so now the cash flow 2. Cash flow 2 only have one payment. We don't know the value T, but the T, we have $80 in total again. Then at time 0, we have X. So if T is somewhere in between 6 and 12, then the present value of these two cash flow may be the same. So that we can solve this for T, at least conceptually. So, okay, so compare the present value at time 0. So compare cash flows at time equal to 0. So that means, okay, so the second one that we have the 80 times the v to the power t. So this 80 is worth 80 times the v to the power t at time 0. Then how about the other side? So the other side, this $10 is worth 10 times v to the 6. In the same way that you can say that this as the 10 times v to the power 6 plus 30 times the v to the power 9 plus 40 times the v to the power 12. And you can solve this analytically for t. So it looks complicated, but if you divide both sides by 80, then take logarithm, then you can solve it. Okay. So that you divide by 80, then take logarithm, so that becomes t times log of v is equal to this 10 times v6, 30 times v9, and the 40 times the v12 divided by 80, and take logarithm. Logarithm is always natural logarithm, otherwise mentioned. So that means the t is equal to on the denominator, the log of v. So the v is known. So v is 1 over 1 plus I. So this is equal to 1 over 1 plus 1.05. So 0.59524. We have seen it before. So the denominator is log of v, and the numerator is the log of the 10 v6, 10 times v to the 9th, 10 times the v to the 12th. And okay, so this is fraction, so minus log of 80 because of the property of logarithm. So you can calculate this, and the v is just a number. So you plug in number, then you can solve this for t. And t is equal to the 10.016. So approximately 10.02 years. So this is the answer. So the difference between the previous question and this question is that the first one we solved for I. This one, the equation is solved for t. And the second one, so for t, actually we can get the analytical solution. So you don't really have to use the BA2 plus. Okay, so if you only have the 30 seconds to answer this question, and you just would like to get a rough estimate for this t, what should you do? And we can use a linear approximation, basically. So you can see that this $80 is the same as the total of this 10, 30, and 40. So if we think about the weighted average of this 6 and 9 and 12 years, then you can get T. So just the weight is 10 and 30 and 40. It's just a rough approximation, a linear approximation. So we have the $10 at 6, $30 at 9, $40 at 12. So just we use 10, 30, 40 as the weight for 6, 9, and 12 years. Then the T is approximated. So linear approximation, T tilde is given by just weighted average of 6, 9, and 12. And weight is 10 for 6, 30 for 9, and 40 for 12. So this becomes 10.125. So this is slightly larger than 10.02. So the idea is the average, so the weighted average. Weighted average of the 6, 9, and 12 years. So 10.125. Okay. Yeah, so this is called, this method of approximation is called the method of equated time. So these days we have a computer anywhere, so you don't really need approximation. But in old days, it's really important to quickly calculate a ballpark estimate. Yeah, and the mathematical, interest is, okay, so this is 10.02, and this is the 10.125, and the 10.125 is larger. And if we solve this kind of question, just the weighted average question, actually always T tilde is larger than T. It is known that the T tilde is larger than T if interest rate is positive. So I don't provide a proof here, but basically this is because the effective rate proof idea is that the y is equal to 1 plus I is interest rate to the power t is a convex function. And this convexity gives T tilde is larger than T. So basically it's a Jensen's inequality. So yeah, if you don't have enough time to answer this question, and you got T tilde is equal to 10.125, and in the exam there are several choices, and the answer is 10.02 and 10.32, and others are much larger or smaller. Then you can see this 10.125 should be larger than the true answer, so you can pick this.